Okay, so on your yellow paper, on this side, this is a little chart of all of the rules that you have already learned, okay? This is a function that's just written out that kind of has it all in there. They won't all have all the transformations in there. Here's something I want to make sure that you notice here. With the b, if there's more than one term that goes with the x, you need to factor that out every time. You can, if you understand how the transformations work and when you factor it out what happens and when you don't, what happens, that's fine if you can get them done right. But we're going to look at some functions that you have never seen before. That's not the signum that we're going to talk about today. And you're going to need it factored out every time. So really what's best for you is just to be consistent. And if you always factor it out, then you will always do everything in the same order and you won't have to overthink it and get confused. Okay? So once we get to some examples, I'll restate all that, but that's why it's done like that. There's also a reason I have minus c and plus d. Because your x lies, right? Whatever looks like happening with x is actually the opposite. So with your horizontal shifts, when you have x plus a number, you're actually going to the left. X minus a number, you're actually going to the right, right? We know all that. Vertical, when you're dealing with y though, if it's plus, it's up. If it's minus, it's down. Reflections, if you change the sign on y, it's across the x-axis. You change the sign on x, it's across the y-axis. Your stretches and compressions. If b is a fraction, then like if it's 1/2 x, that's actually a stretch by a factor of 1 over b, which would then be 2, and so forth. And then vertical is what it actually looks like, and we'll look at those again in a minute. But that's something just for you to see what it looks like in function notation, what's actually happening to the coordinate as well. And obviously more than one of these things could happen at a time. So on the other side of that, kind of break this down a little bit. When you translate it, which can also be called a shift, but it's a translation, up and down, that's a change of which value, x or y? Y. So if I'm going to shift it down, my y value, which is f of x, would be minus what letter? D, right? Minus d. If it goes up, then f of x plus d. When I translate left and right, that's going to change which value? X. And so f of, and if it's a left, remember x lies, so it's x plus what letter? C. And if it's to the right, it's f of x minus c. Reflections in the x-axis, you're changing the sign on y. Your y is f of x, so to change the sign, it looks like that. When you reflect in the y-axis, you're changing the sign on x, so it looks like this. So that's, you're adding and subtracting and technically multiplying or dividing by -1 on these. But then your dilations is when you're multiplying your coordinates, right? You have a stretch or a compression. If they are vertical dilations, you are affecting which? The x or the y? It's vertical. The y, okay? So the compression would be a times f of x, and the stretch is also a times f of x. But what makes them different is your value of a, right? So if it's a compression, it's vertical, so that's with the y, then it has to be less than 1. So the absolute value of a has to be less than 1, but greater than 0. And I just realized I did this first instead of finishing the parent functions. I don't know why, but it's fine. We'll do this and then we'll go back. It's fine. It doesn't really matter. The stretch, that's going to be greater than 1. So the absolute value of a is going to be greater than 1. Because the sign that may be on a would give you the reflection, right? That's a different part of that. So the function will compress or stretch vertically by a factor of a, the absolute value of a. The compressions for horizontal affects the x, right? So this would be f of b times x for the compression or the stretch, but the difference is the actual value of b. If it is a compression, b is greater than 1. So the absolute value of b is greater than 1. So if I have f of 4x, that's actually a horizontal compression of 1/4. You use the reciprocal of whatever it is. Yes, because if it was like 2/3 or whatever, you use the reciprocal. Yes, thank you. So stretch, the b, absolute value of b, would have to be less than 1 and greater than 0. So you use the reciprocal when you're multiplying for x. You use the opposite sign when you're adding or subtracting because x lies. So the function will compress or stretch horizontally by a factor of the absolute value of b. Okay, we good? Any questions? All right. So let's go back to the pink paper, which is what I meant to do first. But again, it doesn't really matter. Yes, and I realized yesterday I saved the wrong version. I saved the blank version, but that's okay. We didn't have much written for signum anyway. But before we talk about signum, I want to go back up here. We talked about square roots and the fact that those were directly related to quadratics, and the cube root was directly related to the cubic, right? Because those were what kind of functions? Inverse functions. Okay, so the logarithmic is the inverse of what? Exponential. Yeah, it's not an inverse of itself, but yes. So with that said, let's see. I didn't. Okay. If I have, so I have f of x is equal to log. We had a log base 10, if it doesn't really matter. I'm going to use log base 8 just so I have something to write. So not thinking about inverses because I'm not actually going to switch anything, right? But I'm not going to exchange the x and the y here. But can I take my log function and rewrite it as something else that I could actually maybe figure out some calculations on? What can I rewrite it as? It's all algebraic, but an exponential. Since it is the inverse, that's how you solve it, right? So if you were going to do the inverse, when you exchange x and y and you have to solve for y, that's when you have to use the log, right? But even if I'm not doing an inverse and I'm not exchanging anything, I can rewrite. Can you just do logs in your head and you know what they are? Probably not, if I had to guess, right? I mean, it's just not something that naturally comes to most people. But exponentials are something that you're more capable of actually figuring out. Would you agree with that? So I can rewrite this as an exponential. I'll make this y so it looks a little bit better. So y equals the log base 8 of x. So if I'm going to rewrite it as an exponential, what's the base of my exponential expression? 8, because the base of this is 8. What's the exponent? Y equals what? X. So the base to this power equals that part, right? That works for every single log. So this is something that you are more capable of figuring out, right? Now, you substituting in x and getting y, you got to use logs for that. But when you are trying to figure out some points, like we figured out our key points or our anchor points, and if you look at that log one, I know we used 10, and I'm using 8 here, but instead of substituting in x, I can substitute in y, right? So when y is 1, what's x going to be? When y is 1, 8. When y is 0, what's x? 1. When y is -1, what's x? 1, 8. And you see how you get that? And you can reason through it better than it being a log and you being confused. Okay? If I blew your mind by rewriting this, algebra 2, I don't know what to tell you. Okay? So all I'm saying is you can get a t-table when you're doing logs without a calculator by changing it to an exponential and getting a few key points. You don't have to get 1,000 points. You just need a few of them to just get the shape, and then you're good. Okay? Any questions? But you got to know where to start, because if you're trying to graph a log that's going to look something like this in the end, right, and you're trying to substitute in points, and you're substituting in some x's over here or something like that, or you're substituting in y's that are way up here, that's not going to help you any. You have to understand what's happening with the transformations so you at least know where to start to get a couple. But honestly, if you, whatever the base is, if you use 1, 0, and -1 at the parent level, you can get a few key points and then just translate things around like we're going to do. Okay, we good? All right. So I just want to remind you of that because we didn't talk about log and exponential being inverses, but they are, and they are definitely related to each other. All right. So then let's go back and let's talk about signum. I'm pretty sure what we got written down yesterday was that we have SGN of x equals the absolute value of x over x. We at least got that far, right? And then we know that x cannot equal 0. So then I'm not going to cram it all in there, but for the most part, that kind of is how you will use it some where you actually don't even use this point. Or you can use that and then also make a statement that when x equals 0, then y equals 0, that sort of thing. But we can also rewrite this as a piecewise function. In on-level algebra 2, I don't think you do piecewise. And pre-AP you do. I'm not sure that you do a whole lot, but you did do some. This one is super basic, and we'll talk more about piecewise next week. But because this is a function, does it pass the vertical line test? Yeah, it totally does, right? It passes the vertical line test, and so it is a function, and it's just in pieces. We understand the pieces, right? This is a horizontal line, so y equals -1. But y doesn't always equal -1. It only equals -1 when x is less than 0. Y equals 0, but only when x equals 0. And y equals 1, but only when x is greater than 0. So there are our pieces, right? Okay, so little side note here, a little life lesson for you. It is important that you get to a point in your life where you are comfortable with admitting when you're wrong. Y'all know anybody that just never can admit when they're wrong? Even when it's like glaringly obvious, you're like, dude, you're looking like a fool, all right? So people will respect you a whole lot more if you go, you know what, I messed up. I made a bad decision, or I was just wrong, or whatever. And you just move on with your life, and you'll feel better about it, and whatever. Okay, so here's like a little confessions of a bad teacher, right? Because I'm wrong all the time. I'm not perfect, and it's not even like I can try to hide that, and I know that. But I want you to understand, I don't want you to lose faith in me like I have no idea what I'm doing, because I really do. I sort of just made some stuff up the other day. I can't even tell you exactly where it came from. I can tell you why I did it, but not like what my brain was thinking. So in the past, this pre-cal course has not always focused very much on preciseness as it should have to help you be precise when you get to calculus. And so last year when I was trying to kind of follow along with others, you know, when we would do domain and range or any sort of little intervals like that, any kind of notation was fine, which is, there's nothing really wrong with that, except it was also kind of okay to mix things and only half do it. And it was driving me crazy, but I was like, well, whatever. I'm just trying to make sure I know doing what's right for them. It was definitely not what was best for everybody. So this year we decided we were going to make sure that you knew exactly what the different ones were, and we were going to focus more on interval because that's really what you need, but that doesn't mean that you don't ever see the others. So in doing so, just like if you said the domain is all real numbers, that's a true statement, but that is set notation, right? So that's, you know, we're actually saying specific notations, which SAT tests, AP tests, it may not even tell you specifically what to use, but you still need to know the differences, and if it does say, you need to know what to do and what that means so you don't miss it because you didn't do the notation right. So with that said, I want you to turn to page 25 in your ISN. And here's what happens. Because I did just completely make stuff up. I don't know. So when we talked about the different types of notation, right, so that we could actually do what it was being asked when. I've had lots of discussions about inequality notation with lots of adults, and we've looked at lots of things up, because I think some of us even hadn't really ever thought about this is all inequality, this is all set, and so forth. But we do need to make sure that we can split those things up. So people kept telling me, you can never use infinities with inequality notation. I said, that does not make any sense. How the heck am I going to do the domain if I can't use infinities? Like, that doesn't even make any sense to me. Well, that it's all real numbers. Yes, but all real numbers is set notation, right? So how do you do all real numbers in inequality notation? And this is correct, by the way. So I wasn't the only one that went, oh, okay. And then I honestly have no idea why I did some of the stuff that I did. I don't know. I just made it up. I don't know. But so this right here, I'm just like, I don't know. It's not really wrong. It's sort of wrong. It's wrong. I'm not trying. It's wrong. But like this right here, do you need to say that it has to be less than infinity? Think about that. No. I mean, in interval, you need to say that because you have to have the other side of the interval. But this part right here, totally not necessary. And not even what you would do for inequality notation. I don't know why I did that. So just that part, even written that way, is okay. But most likely, if you were going to write that, you would probably write that y is greater than or equal to 0. But you do understand that that's the same thing, right? So, but forget, you only use the infinities when it's like an all real numbers situation, okay? Otherwise, they're not used there, which is, you've probably never seen it that way before, but that's, I think, because I just made it up. I don't know. I don't even know why I thought that was right. I don't have a good reason for that. So, yes, exactly. So here, well, not if it's all real numbers. Like this has to be like this, and this is correct. This right here, we would just not put that part. Here, I would just not put that part. Does that make sense to you? Like, so you only use it basically when you have to. Otherwise, if I say x is greater than or equal to -3 or less than infinity, well, duh, everything's less than infinity. Like, you can't, it's kind of obvious. So that's good because that's less writing. But in whether you write it this way, although I think myself included, I naturally would put the x first and say x is greater than or equal to -3, but that's not wrong. And then same thing here, we would kind of knock those off. Does that make sense? So, well, no, probably not. Because again, even though I don't think it's a false statement, it's just not what inequality notation is defined as, but I don't think you would get it wrong. Does that make sense to you? Because very few things will specifically, and if it does say specifically, it probably won't say inequality. If it specifically tells you, it is most likely going to specifically say set notation or interval notation. Does that make sense to you? Okay. All right, so I just wanted to clear that up. Sorry. It's nothing major. It's not like well, I did teach you wrong, but yeah, nothing major. I don't know what I was doing. All right, so with all that said, let's go back to this and finish up the signum. So, still interval notation for pretty much everything, but I wanted to clear that up because you see, the other thing is when I was talking to, so Mr. Ackerman and Ms. Archer and I sit around and we ponder things a lot about specifics that are the minor things, not even the hard concepts. But I said, so when we're talking, we're doing everything in interval notation. When you write piecewise functions, I started to write this in interval notation here, and that seemed weird. So I thought, I don't know that I've ever seen piecewise where you do interval notation here. And so then all three of us were like, well, I don't think it's wrong, but yeah, I don't think I've ever seen that either. So for piecewise, it's fine. We're going to just use inequality. It's a little easier anyway. But that's why I wanted to talk about it again. And I don't think it's some sort of piecewise rule. I'm going to have to find that out for sure that like it has to be inequality. I think it just makes more sense there probably, and that's why it's done that way. But that's why I did it that way and not interval. Does that make sense to you? And I will do my very best to not make all that confusing for you, like when to use what, but that's why I wanted to clear things up. All right, so domain, but in interval notation. The domain of my signum function, what is it? It's all real numbers, but yeah, negative infinity to infinity, which is all real numbers in set notation. Now range, a little tricky. We won't even, is it like all real numbers? Is it from -1 to 1? Okay, but -1 to 1 as an interval implies that 0.5 is in my range, is it? No, it's not. So in this case, I have what's called a finite set, right? Means that there's an infinite number of, even if I did go from just like -4 to -2, there's still an infinite number of points in there, right? Okay, so that's an infinite set. This is a finite set. I literally only have 3 numbers that are in my range. Would you agree with that? When it is finite, then set notation is always fine because it definitely makes more sense. It's -1, 0, and 1. Okay? Finite means it's countable. It's like people on a bus, right? You can't have half a person on a bus. You got a finite set of whatever. All right, or you shouldn't, then the police are coming, right? All right, so x-intercepts. Do I have any? Yes. 0, 0. Y-intercepts? Yes, 0, 0. Extrema. Oh, you're ahead of yourself. Yes, but that's not extrema, but you're on the right track. Yeah. All right, so the smallest y value is what? -1. But I can't really write that as a point because there's an infinite number of points that include that extrema, right? So there's not really an extrema. Tell me that it's none. We're just going to leave that blank because the signum function doesn't fit into this mold quite as well as the rest, so we're just going to leave that one blank. Is it increasing anywhere? No. Is it decreasing anywhere? No. But this is constant, and constant isn't a choice on here just because it doesn't fit most of the parent functions, so we'll write it down here. So our constant intervals would be from -infinity to what? Is it constant from -infinity to infinity? To 0. Good. Do I include 0? No. And then 0 is just a point, so we don't include that either. And then we go from 0 to infinity. in behavior, as x approaches infinity, f of x approaches, and the answer is 1. And I know it's already there before it even starts approaching, but that kind of ensures that once it gets out where we can't see it, like it doesn't start wiggling or anything, right? So or it doesn't shoot up, it's 1. Because, and I know we say it as approaching, but same thing with limits. The limit, you think about getting there, it's okay that you can actually make it there, but we'll just do it this way. As x, you won't be asked this kind of question on this anyway, but just so we fill in the rest of it. F of x, negative infinity, approaches negative 1. So are there any discontinuities? Yes. What kind? Jump. So there's a jump discontinuity. Where? X equals 0, right? At x equals 0. Remember, that's always just an x value there. Is it even, odd, or neither? It's odd, okay? It is odd because I can rotate it 180 degrees. Plus, if I substitute in that negative x, so f of negative x is equal to the absolute value of negative x over negative x. So that's the absolute value of x over negative x, and that is negative f of x. So it's odd. Okay, we good with all that? Any questions? All right, so you can go ahead and glue the pink ones in if they're not. You can glue the yellow one in. The blue one, I thought that we would be able to get to at least, I knew we wouldn't finish it, but I thought we would be able to at least get to a couple of them, but that quiz took longer than I thought it did. So you have it, look over, you don't have to do any of it, it's notes, but look over that yellow form, look over the notes. We're going to start there on Monday, and most of that's a review, okay? But you have plenty of time to glue. I know you don't always have time to glue, but you got time to glue today.